The purpose of this demonstration is to show you and remind you how to balance chemical equations. We do this to satisfy the law of conservation of mass, and this can be done in 3 easy steps. Step 1 is to write the correct formulas for the reactants and products, if they're not given, separated by an arrow. Step 2 is to count the number of each type of atom or polyatomic ion if it's unchanged during the process. And step 3 is to adjust the numbers on each side using coefficients until equal amounts are on each side. We never, ever, ever, ever in the history of forever mess with subscripts once formulas are correctly written. We'll look at these through a series of examples. Example 1 is a simple reaction between aluminum sulfite. It's breaking down to produce aluminum oxide and sulfur dioxide gas. This is a decomposition reaction, and we'll begin by making a T-chart where we will count the amounts of atoms on each side. It appears we have 3 sulfurs, 2 aluminums, and 9 oxygens on the reactant side, and on the product side we have 1 sulfur, 2 aluminums, and 5 oxygens. We'll start with balancing sulfur because it appears in only one location. Placing a 3 in front of sulfur dioxide corrects this, and also in the process corrects my oxygens, so that I've satisfied the law of conservation of mass. Example 2 deals with copper nitrate reacting with solid potassium metal to produce potassium nitrate and copper. Copper 2 nitrate is in this process is going to be a single replacement reaction. Potassium and copper are very similar, both are metals, so they will or have the potential to interchange. We consult the activity series for this and see that potassium is much higher than copper, so this reaction will indeed proceed. We'll begin with another T-chart. We have 1 copper on each side, we have 1 potassium on each side, and as nitrate remains the same on both sides of the equation, there's no need to separate it, so we can count them together. 2 nitrates on this side, 1 nitrate on that side. I'll adjust the nitrates by putting a 2 in front of potassium nitrate, which also produces 2 potassiums. Correct that with a 2 in front of the element potassium, and my equation satisfies the law of conservation of mass. The next level that you'd be expected to do with these balancing chemical equations is to be able to translate from words into a reaction and then balance it. So as we're looking at this, I'm going to underline the things that we need to deal with. So when we do ammonium hydroxide, we need to know that ammonium is NH4 positive. We need to know that hydroxide is OH negative. Reacts with is going to tell me plus. Aluminum nitrate is going to come from Al positive 3, aluminum being a group 3 metal, and nitrate being NO3 negative. The fact that these things go in solution tells me that both are aqueous. To produce is going to be a reaction arrow. Aqueous ammonium nitrate, again, here's my ammonium, here's my nitrate, and we're also going to make aluminum, Al plus 3, hydroxide, OH minus, and precipitate is going to tell me solid. So we're going to put all these pieces together. I've got ammonium, hydroxide. I generate the formula for this by swapping charges. So NH4OH in solution, aqueous, plus aluminum nitrate, again ionic, so swap charges, Al NO3 aqueous. They're going to produce ammonium nitrate, again NH4 plus, NO3 minus, so they just come together like so. So they're still in solution, means aqueous. And it says we're going to produce aluminum hydroxide precipitate. Swap those charges, get Al OH 3. Oops. Let me correct that. going to get AlOH 3 precipitate. Now, as this is a double replacement, two compounds reacting in solution, I have to produce either a solid, liquid, or gas for this reaction to work. I have a solid right here, so this reaction will go. So now I need to satisfy the law of conservation of mass. Looking what's out of whack, nitrates and hydroxides are out of whack. So fixing nitrate, fixing hydroxide, and ammonium falls out with them. And then finally, the most complicated thing you'll be asked to do is to not only convert things from words, but to also predict the products. And this is going to require you to be able to tell what type of reaction something is. If we're looking at lithium metal, that is Li solid. Metals are solid at room temperature. Reacts with positive nitrogen gas. Nitrogen gas is a diatomic, HNO and group 7A. The halogens are all diatomics. So now, I have two elements reacting together. This is hallmark synthesis, so I must combine them together to make one product. Because lithium's a metal and nitrogen's a nonmetal, they will combine according to their charges. Lithium is positive 1, nitrogen is negative 3 when in ionic compounds, so when they get together, they're going to make Li3N. That's an ionic compound, a salt, so it is a solid. We'll mark these out. They don't need to be there. Now I need to balance. Nitrogen has the highest charge, so we balance nitrogen first. That requires me to have 6 lithiums, and I have satisfied the law of conservation of mass.